Hello, I'm Athena and welcome back to Ask STARBASE. Today we're tackling some of the fundamental questions about our solar system, such as how does gravity work? How did the Earth and other planets form? Why do they rotate around the sun? Why is the sky blue? That last question is answered in Ask STARBASE episode 88. But let's take a look at those other questions together because they're all related to each other, and the main reason is gravity. Why do you land on the ground when you jump up instead of floating off into space? Why do things fall down when you throw them or drop them? The answer is gravity, an invisible force that pulls objects, anything with mass, toward each other, including objects in space. Objects with more mass have more gravity. Gravity also gets weaker with distance, so the closer objects are to each other, the stronger their gravitational pull is. Earth's gravity comes from all of its mass. All its mass makes a combined gravitational pull on all of the mass in your body. That's what gives you weight. And if you were on a planet with less mass than Earth, you would weigh less than you do here. Our solar system formed about 4.5 billion years ago because of gravity, starting with just a dense cloud of interstellar gas and dust. When the cloud collapsed, which happens in the universe, things explode all the time, it created a flatter, spinning disk of material called a solar nebula. At the center, gravity pulled more and more material in. Eventually, the pressure in the core was so great that hydrogen atoms began to combine and form helium. This chemical reaction also released a huge amount of energy and gave birth to our sun, taking it more than 99% of the matter that was around. Beyond the gravitational pull of the sun, and other matter in the disk was also clumping and smashing into each other, forming planets and moons. Their distances from each other helped them pull each other into round objects. Other smaller leftover pieces became the asteroids, comets, meteoroids, which run through the solar system, pulled along like a chain from one gravitational orbit to another. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest to the sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first 4 planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They are all small, with rocky, solid surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Gravity is very important to us. We could not live on Earth without it. The sun's gravity keeps Earth in orbit around it, keeping us at a comfortable distance to enjoy the sun's light and warmth. It holds down our atmosphere and the air we need to breathe. Gravity is what holds our world together. You exert the same gravitational force on Earth that it does on you, but because Earth is so much more massive than you, your force doesn't really have an effect on our planet. Today we know about 4 fundamental forces in the universe, things that attract or repel one object to or from another. The strong force and the weak force operate only inside the centers of atoms. The electromagnetic force rules objects with excess charge, like electrons, protons, and socks, shuffling over a fuzzy carpet, and gravity steers objects with mass. The first 3 forces weren't deeply researched until the past few hundred years, but people have long speculated about gravity, which acts on everything from raindrops to cannonballs. From ancient Greek and Indian philosophers to Isaac Newton and beyond, gravity has been noticed for quite some time. It was Isaac Newton that realized gravity wasn't just something that happened, but that it was measurable and predictable. He realized that every object in the universe, from a grain of sand to the largest stars, pulled on every other object. He also put numbers to the attraction. Doubling the mass of one object makes its pull twice as strong, he determined, and bringing 2 objects twice as close quadruples their mutual tug. Newton packaged these ideas into his universal law of gravitation. This description of gravity was accurate enough for scientists to detect other planets, such as Neptune, in the mid-1800s before anyone could see it. But Newton's law isn't perfect. Also in the 1800s, it was observed that Mercury's orbit was moving more quickly around the sun than Newton's theory predicted it should, suggesting a slight mismatch between his law and the laws of nature. The puzzle was eventually resolved by Albert Einstein's theory of general relativity, published in 1915. Before this, scientists knew how enough of the general workings of gravity were to calculate a planet's gravitational pull, but their understanding of why gravity behaves so hadn't grown much since that of the ancient philosophers. It worked basically as Newton had theorized, and that was good enough. But while working on his theory of special relativity, Einstein had determined that nothing could travel instantly, and the pull of gravity should be no exception. He suggested that the shape of space-time is what gives rise to the force we experience as gravity. A concentration of mass or energy, such as the Earth or Sun, bends space around it, like a rock bends the flow of a river. When other objects move nearby, they follow the curvature of space. We see planets orbit and apples fall because they're following the paths of gravity through their part of space in the universe. In everyday situations, those trajectories match the force Newton's law predicts. So to recap, matter has mass. The more mass it has, the more it pulls on other objects with matter and mass because of the force of gravity. If the objects combine, they will add their mass together and increase their gravitational pull up to a certain distance, pulling planets and moons into the orbits we see today. I'm Athena, and thank you for joining me on another episode of Ask STARBASE. Please submit your questions to ask@starbase-ct.com. See you soon!